Hello students. So this is our DME2 class. In our subject, we were covering the topic of clutches. Till now we have discussed about single plate clutch, multi-plate clutch and cone clutch. Now in this today, session, we will discuss about centrifugal clutch. So before starting centrifugal clutch, you should understand the concept of centrifugal force. First of all, what is centrifugal force? Look at this object which is revolving in a circular path, and this object is experiencing a force which is acting away from the center of the circle. This arrow represents centrifugal force which is directed away from the center of the circle on which the object revolves. So this is centrifugal force, and the concept of centrifugal force is used in the construction of centrifugal clutches. So let's see the construction of centrifugal clutches. In centrifugal clutch, there are two shafts as usual, driving shaft and driven shaft. So the purpose is to engage and disengage the power from driving shaft to driven shaft in quick manner. Okay, so this yellow one represents the driving shaft. This brown one represents the driven shaft. This driven shaft is connected to the pulley, or we can say a rim. This side view represents the circular rim or pulley, which is connected to the driven shaft. And the driving shaft, this yellow one, see in the side view, this yellow one is the driving shaft. It has four springs. These one, two, three, four springs. These four springs are connected with these shoes. This red color shade represents the shoes. Okay, it is a friction material of the shoes, and these shoes are movable. That is, this shoe can move up and down. This shoe can move right and left. Means this shoe can reciprocate. Okay, so it's very simple in construction. Now, when the driving shaft rotates, it rotates at high speed, and the shoes will experience a centrifugal force. That this shoe experience a force in upward direction. This shoe experience force in left direction. This shoe experience force in right direction, in downward direction. So all the four shoes experience centrifugal force, which takes it away from the center of the circle. Due to this, four of the shoes will move away from the center, and this will happen. The four shoes are going to touch the inside of the pulley, the inside of the rim. Okay. And due to the friction between the shoes and the pulley, because this red color shade represents the friction material like asbestos or ferrodo. So due to the friction, the power is going to get transmitted from the driving shaft to the driven shaft. So this is the engaged position of the clutch, means the shoes are in contact with the pulley. So when the driving shaft rotates at high speed, the shoes will experience the centrifugal force, and they will touch the pulley or rim, and the power is going to get transmitted from the driving shaft to the driven shaft. Okay, so this is the concept of centrifugal clutch. So let's see. It consists of a number of shoes in the inside of the rim of the pulley. So as you see, this is the pulley, and we have four shoes. So we have a pulley or rim, and inside the pulley we have shoes. The outer surface of the shoes are covered with the friction material. These four red shades represents the friction material. Okay. These shoes, which can move radially in guides, are held against the boss on the driving shaft by means of springs. So we have four springs which hold these shoes in position inside the guideways. These L-shaped angles represents the guideways in which the shoes can reciprocate. The application of centrifugal clutches in sweepers, mowers, chainsaws, lawn mowers, or fans. Basically, centrifugal clutch is used in application where the torque transmission requirement is less, where we don't have to transmit high amount of torque. Okay, so where the torque transmission requirement is less, and in these applications we can use the centrifugal clutch. So from the diagram you can see that there are two forces acting on the shoe. First one is the spring force, which try to bring the shoes back to the center. The springs always try to bring the shoes back to the center. and there is a centrifugal force acting on the shoes which try to take the shoe away from the center. Okay, so based on these two forces, the clutch will be in engaged position or in disengaged position. So the spring exerts a radially inward force and the centrifugal force exerts radially outward force. So the magnitude of centrifugal force depend upon the speed at which the shoe is revolving. So, centrifugal force actually depend upon the rotational speed. The more the rotational speed, the more will be the centrifugal force. Now see from this diagram, as I have told you that spring will try to bring this shoe towards the center, and the centrifugal force will try to bring the shoe towards the rim. So if the spring force is more than the centrifugal force, then the shoe will not touch the rim and the power will not transmit. When the spring force becomes equal to the centrifugal force, then the shoe will be floating. It may not touch the pulley, but it will be floating. Okay. But when the centrifugal force is more than the spring force, then the shoe will be in contact with the inner surface of the pulley and the clutch will be in engaged position. And we can say the torque will be transmitted. So the increase of speed causes the shoe to press harder. As we increase the speed of the driving shaft, the shoe will press harder on the pulley and the more torque will be transmitted, because at high speeds centrifugal force will be more and spring force will be comparatively less in the centrifugal force. Means centrifugal force will be larger or greater than the spring force when the driving shaft is rotating at high speed. So this is the principle of centrifugal clutch. Hope you guys understand. In the next session, we will discuss its design. Okay, guys, thank you.